How will each of the following affect the rate of the reaction CO gas plus NO2 gas producing CO2 gas plus NO gas if the rate law for the reaction is rate equals K times concentration of NO2 to the power of 2. Part A, decreasing the pressure of NO2 from 0.20 atmosphere to 0.10 atmosphere. Part B, increasing the concentration of CO from 0.03 molar to 0.09 molar. First, let's summarize the information given to us and what we need to find. First, we know the reaction is between CO gas with NO2 gas producing CO2 gas plus NO gas. Next, we know the rate law for this reaction is rate equals K times concentration of NO2 to the power of 2. And we know that part A asks us that if they decrease the pressure of NO2 from 0.2 to 0.1 atmosphere, what's going to happen to the rate? How the rate is going to change due to that decrease. So first, to learn what's going to happen to the rate, we have to understand what does the rate depends on. And to do that, let's look at the rate law for this reaction. So the rate law, as they provide, they said rate equals K times concentration of NO2 to the power of 2. So this is a second order reaction where the rate depends on the concentration of NO2. So it leads to this question that does the change in pressure of NO2 also change the concentration of NO2? Because if yes, then the rate will change if the pressure of NO2 changed, right? So yeah, the answer to this question is yes. And this is according to Henry's law. So the Henry law, it says that concentration of a gas is directly proportional to the partial pressure of that gas. What this means for us is when partial pressure of NO2 decreased by 2, like going from 0.2 to 0.1 atmosphere, then the concentration of NO2 will also decrease by 2. So this means that the concentration of NO2 after the change to the pressure is going to be 1/2 of the original concentration of NO2. So it means that the original rate is K times the original concentration of NO2 to the power of 2. And the after change rate is going to be K times the concentration of NO2 after the change, also to the power of 2. And like we highlighted right here, the concentration of NO2 after change is 1/2 of the original concentration of NO2. So once we substitute that in, and we can isolate the 1/4 outside, we will see that the after rate change is equal to 1/4 the original rate of this reaction. So in conclusion, we have that decreasing the pressure of NO2 from 0.2 to 0.1 will decrease the rate by 4. And that's for part A. Now let's move on to part B. Part B asks us that if they increase the concentration of CO gas from 0.03 molar to 0.09 molar, what's going to happen to the rate? So again, we're going to look at the rate law for this reaction. Rate law says rate equals K times concentration of NO2 to the power of 2. So we know here that the rate doesn't depend on concentration of CO gas at all. It only depends on the concentration of NO2 gas. Therefore, so the increase of CO gas from 0.3 molar to 0.09 molar will not affect the rate at all because the rate doesn't depend on concentration of CO. And that's the answer to this problem. Thank you for watching. Please subscribe if you like our content.